Okay, hi guys. Okay, welcome back to the first session of operating system concepts. Okay, operating system concepts, and here we are going to discuss some basic concepts about operating system architecture. Okay, now let's start. Let's begin with the question answer session because for your kind information, all our sessions will uh, will be in question answer session. Okay, so there will be a specific question related with the concept. Okay, and the specific answer is provided, and this and overall at the end it will try to answer all your questions, okay, that was raised previously before starting the course, right? Okay, so what is the operating system? In a simple meaning, operating system is something as an interface, act as an interface, okay, between user and a computer hardware. So it's like something it acts as a mediator between a user. User is somebody like us. We are the user. We use computer hardware, but there is a mediator. So which provides the easy way to utilize the hardware to solve our problems, okay, and perform the jobs. And this is the operating system. So operating system executes the user program and solves user problems. So all the kind of user problems. Okay, all the user problems are solved here. Okay, execution of the programs. Okay, everything is done. Right? Operating system makes the computer system. Okay. So overall it makes the computer system easy and convenient to use. As I already stated before, this is at the end this is always trying to make accessing, okay, or using the computer hardware very easy and convenient to the user. It is like it makes user friendly. Okay, there are very different kind of definition for operating system. So firstly, we can also define it as a resource allocator, because it manages and allocates resources. It allocates the resources and manages it. So who wants the resource and when does it want? When did he ask for the resource, or how much time is he going to access the resource, or how many resource must be allocated, so the size of the resource, all this information is all done by all this query, okay, all these actions are performed by the operating system. Whereas also secondly, it is defined as a control program. Control program is something that it controls. Why it is defined as a control program? Because operating system controls the execution of user programs and operation of IoT devices. So it can also be defined as a control program. And lastly, it can also be defined as a kernel, because one program is running at all time, and that one program is something that is called operating system from beginning to the end. When you first switch on your computer till when you switch off your computer, okay. So operating system is always running and providing services and making easy, okay, to use the computer hardware, making computer very user friendly. Okay, now let's jump to the second question. In the second question, we have stated what is this simple batch systems then. This was one of the very first version of operating system. Okay, before the current version is very different from the previous versions, because all the operating systems where it is just the development of the previous operating versions that were developed. So simple batch system, among them simple batch system is one of the earliest version of operating system, and it works on the principle of automatic job sequencing. And what is automatic job sequencing? It's something like we automatically transfer the control from one job to another. Okay, so there are various kind of job, and the control of the job is transferred automatically from one job to another. And specifically it consists of resident monitor. And what is this resident monitor? Is something like its initial control is in the monitor. Means monitor is something like a controller. Okay, the initial control is in the monitor, and then the control transfers to the job, and whenever the job completes, the control transfer back to the monitor. So like monitor is something like a captain, okay, who is going to transfer the control to the some certain jobs, and whenever after the job is done, the control transfers back to the monitor. Okay, so it's like a control provider. Now what is the memory layout for the simple batch system then? How is the memory structure? Okay, so the memory layout consists of two halves. Okay, it's divided, the whole box, the memory box is divided into two halves. The first half is for the resident monitor, and the resident monitor, as I already told you, the resident monitor is something that transfers the controls to the job, and after the job is done, the control is taken back, right? So the first half of the memory block is for this resident monitor, whereas for the second half is for the user. Okay, in the monitor area we have like the interrupt and tab vector, okay, to call the interrupt or to, and then we also have the device driver, we have job sequencing, control card interpreter, so everything is there. And what separates the size, what defines the size among, so which size is like one half is how much the first half is how big. Okay, the size is determined by the fence register. Okay, now jumping on the next question, we see that in a simple batch system, how does the monitor know about the nature of the job and which program to execute? Okay, to distinguish a job from job or data from the program, we introduce control cards. So to know the nature of the job or to know which program to execute, okay, to distinguish all these activities, we have to use the special a special tool is created, that is a control card. And what are these control cards then? These are some special cards that tells the resident monitor, okay, which program to run. Okay, mostly it is just act as some helper to our resident monitor because resident monitors is somebody who, like something that is going to transfer the control to the job. So but which job has the priority, so which job to perform, and like how do you distinguish from job and how do you distinguish from the data? Is it a job? Okay, so the resident monitor must understand if it is a job. Okay, to transfer a control, so you need to distinguish is it a job among all the statements, it is a job or is it not a job, so it is a data. So the difference between this is just detected by a control card. Okay, and look, we can distinguish these control cards from data program cards, because for example, this is a data, okay, that is totally different from this kind of um, control cards, okay, and this is a particular job. And these are data, okay, they are totally different, because a job has a keyword that is a dollar sign, whereas a data may have different sign. And from this particular keyword, okay, we distinguish that this is a job and this is a data. Okay, and this kind of control cards distinguish that these are jobs, and tells the resident monitor that these programs must be executed, or this program, the control must be passed to this program. So what are the parts of the resident monitor then? Okay, it consists of control card interpreter, okay, and this control card interpreter is responsible for reading and carrying out instructions on the card, whereas it consists of loader that loads system programs, application programs into memory. Okay, it just performs the action of loading the programs and applications. So whereas it also consists of the device drivers, which helps to run each of the system's I/O devices, knowing all its special character and properties. So it just helps, device driver just help, okay, it just helps us to run each of the input-output devices, because the device driver already know the special character and properties required to run this kind of devices. Okay, so it consists of most important three parts. Okay, we have three most important parts in resident monitor. Okay, now, like, how will you solve the problem to show performance in simple batch system? How will you solve the problem to show performance? And the performance is measured in a certain criteria, and this criteria is called throughput. And throughput is something that is is an amount of job per total time taken. Okay, so whatever amount of job performed within a particular time is defined as a throughput. And in the case of a slow batch system, we can directly say that it is very low. Okay, the throughput is very low. Like, for example, we can say 32 jobs per hour. It can perform 32 jobs per hour. And this is what may be the cause of this slow throughput, very low throughput, is because of the very slow card reader. Okay, the card reader is very slow, and also because the input, output and the CPU do not overlap with each other, so they do not work parallel with each other, they do not overlap. Okay, so maybe like input output is slow or CPU is like very fast, so some kind of difference is there. So this is the problem. Okay, and this problem of slow performance is existing in the very first version of operating system, and that is simple batch system. And how can we solve the problem? Okay, so we can solve the problem by doing offline operation, right? So this offline operation consists of loading jobs into memory from tapes, and what it does is like the card reader and the line printing is all done offline. So this means like something under the hood. Okay, the card reading and line printing job is performed under the hood, so it's done offline. And by doing this, okay, by doing the pre-job that is required, okay, offline, we can just very fast, we can just increase, okay, like we can increase our throughput to almost like 55 jobs per hour. Okay, just by this particular concept, principle, using the particular principle of this offline operation, we can just increase the throughput by such a huge amount. Okay, from 32 to 55. You understand me? Okay, so this is just about solving the problem of performance. Now going through the multiprogramming batch system. So what is this multiprogramming batch system? This is the second version. Okay, this is the upgraded version of just an upgraded version just above the simple batch system. It came just after the simple batch system. And what is done in this multiprogramming batch system is we take several jobs and keep it in main memory. At the same time, several jobs are taken and kept in a main memory at the same time, and the CPU is multiplexed among them. So in the same memory there are several kind of jobs, and the single CPU is multiplexed, okay, among all these jobs that are loaded in the main memory. So we use this special technique. There is a special technique called spooling. And spooling is something that in reading part we read the next job from card reader into storage area on the disk. So there are two specific part, like reading part and the writing part. Okay, so in reading part we read the next job. We already read the next job from the card reader. So already the job is already pre-done. Okay, so reading part is already done. What is the next job? Okay, the reading part do the reading of the next job, and for the writing part we just output the previous job. So whatever is the previous job is already output. Okay, it's printed out. So reading and writing, okay, they do some kind of specific task, and which helps in multiprogramming. Now this job pool is a data structure that allows the operating system to select which job should be run next, okay, to increase CPU utilization. So job pool is something as just a data structure. Okay, now discussing about the multiprogramming, we have like what kind of operating system features we need for multiprogramming. We need there is some specific features, okay, which are different from that was some advanced features than a simple batch system. We need, like, system must have input and output routine. Routine means something like data input and output data flow, the streams. Then memory management must be done for several jobs. So CPU scheduling should also be done to choose among several jobs, okay, ready to run. So we have to also allocate the devices. So these kind of specific features must be performed in multiprogramming. And in this multiprogramming provides this kind of specific features, okay, operating system features. Now about the next system that was developed was a time sharing system. So what is this time sharing system? This time sharing system is something like various jobs are kept in the memory on the ticks to execute. Similar like multiprogramming system, various jobs are kept in the memory. So we perform time sharing by multiplexing the CPU to several jobs. So the idea is basic principle for time sharing systems is like just we multiplex the CPU. Okay, CPU is multiplexed to several jobs. All the jobs are stored in the memory, and the CPU is multiplexed each time having a particular specific time is multiplexed, like for 1 second. So after each second the multiplex like shifts. Okay, the job is shifted to the another job. So by a simple principle of multiplexing, the CPU performs all the jobs. Okay. And the key concept we have to understand is like only the CPU is allocated, or the memory, like the multiplexing occurs for the job if the job is inside the memory. Otherwise the job is not performed, or the multiplexing do not occurs for the job. There is no time sharing for the job. Okay. Now, so various swapping of the jobs in and out of memory is occurred. So swapping in and out, job in and job out of memory is occurred. Online communication between the user and the system is also provided in time sharing. Time sharing swapping was provided. Online communication between the user and the system is provided. So that means like a user can, before finishing the job, the user will get a notification, and after finishing the job, the user also have a notification, and he can just control it from the external devices like keyboard or something, and this communication is provided to the user, and you can use the external executing command, like the command from the key, just to control. Okay, now what are the personal computer systems then? The next new version of system that was developed, personal computer system. These are the systems which are just made for single users. Okay, made for a particular specific task for a single users only. And right now, okay, the note I was trying to tell you is just all these systems was just about the migration of operating system concepts and features till now, because the migration was from simple batch system to multi-programming batch systems, then we arrived to time sharing system, then again lastly to the personal computer system, right? And then also we will go further. Okay, we went further to further migration to some other system, and these are coming. So the further migration was like the parallel system. And what is this parallel system? And these are the systems which are multiprocessor systems with more than one CPU in close communication. So there are more than one processor, physical processor, which are in communication with each other from data cable or some very fast communication media. And all these processors, they share the memory. They share a single memory and the clock, so that the communication takes place among those in the same memory. Okay, so these are parallel systems having several processors but communicating in a same memory. And further about the parallel systems, we have two types of parallel system, that is symmetric multiprocessing and asymmetric multiprocessing. In symmetric multiprocessing, each processor runs an ideal copy of the operating system. Okay, and all these processes run at once without any performance deterioration. So all are performed parallelly. Okay, right? Whereas in an asymmetric multiprocessing system, each processor is assigned a specific task. So each processor has their own specific tasks which are independent of one another. And this kind of systems, asymmetric multiprocessing system, are used in very large scale systems, whereas symmetric multiprocessing system are used mostly in the computers, like the normal computer like we are using nowadays. Okay, and further improvement was like also distributed systems. And in distributed system, the computation among several processors. Okay, so each processor has their own local memory, and so that the processor communicate with the high speed lines. Okay. And lastly, about the real-time systems, these real-time systems are mostly specifically designed for a specific task. Like when if you are performing some experiment, then only so this kind of real-time systems are used, or controlling some music like industrial equipment or such and such. So it has some kind of specific time constraint, and they have the advantage of resource sharing, reliability, and speed up also. Okay, now thank you for listening. Now we will continue on the next session.